All right, so let's take a look at some rational functions. Distance is equal to rate times time, and we use the dirt circle in class. So the dirt circle, distance is equal to rate times time. So if you have just distance and time, distance divided by time would give you rate, or rate times time would give you distance. So in this first problem, I'm traveling at a rate of 30 miles per hour. So let's put that in our dirt circle as our rate. How far can I drive in 1.5 hours? That's our time. So we're going to take the number 30 and multiply by 1.5. 30 times 1.5 is 45. And let's look at our units, miles per hour. So I can go 45 miles. All right, now I'm traveling at a rate again of 65 miles per hour. How long will it take me to drive 180 miles is my distance. So I'm going to take 180 and divide by 65. So it did not come out even. I'm going to say 2.8. About 2.8. It was miles per hour, so it must be 2.8 hours. Jada is planning a kayak trip. She finds an expression for time to paddle 10 kilometers upstream. The speed of the current is in kilometers per hour. This is the graph she gets. So here's her graph. What did we say? T of S, this is hours. And hours it takes her to paddle 10 kilometers upstream. The speed. Oh, S is the speed. So sorry. This is her hours. And this is her speed. Okay, so it looks like we probably don't care about this part of the graph because she's not traveling a negative amount of time. If the speed is about 1 kilometer per hour, how long will it? So let's see, 1 kilometer per hour, how long will it take to paddle upstream? So if I go to 1 on the x-axis, I don't know, around 2 hours, it's just above. So maybe 2.1 hours or 2 hours, I would count correct. The speed is now 4. How long will it take? Here's 4 on the x-axis. Let's see. This is counting by 2s, so it's not quite halfway. You want to call that 6.5 hours, maybe 6.5 hours. Why does it make sense that as the speed of the current gets faster, it's harder to paddle upstream, right? Because you're battling against that current. So your trip takes longer upstream. She's allowing S to take on any value between 0 and 7.5. What's a more appropriate domain? So it looks like our graph goes up exponentially at 5.5. So it looks like the speed of the current is never going to be more than 5.5. So it would make sense for us to look at S between 0 and 5.5 instead, because I don't care about this side of my graph. And it looks like that vertical asymptote is at 5.5. All right, so here's a quote from a printing service. This is the average cost per yearbook. So if I plug in 50 yearbooks, I'm plugging in 50 for the X's. You need to be careful when you type this into the graphing calculator because you want to put your numerator always in parentheses. So 100 plus 8.5 times 50, close parentheses, divided by 50. Looks like it would cost $10.50 per yearbook when you order 50 of them. Now I want to order 100. So now I'm going to do 100 plus 8.5 times 100 divided by 100. Looks like it only is $9.50. So the more you order, the less your cost. Now it says, what if I wanted the average price to be less than $9? I could take a while and guess and check, or I could go to my y equals menu and plug in the original function, 100 plus 8.5x divided by x, and I already know that I want to go to more than 100 yearbooks. So I'm going to start my table at 100, count by 1, go to second table, and just start arrowing down not sure how far I have to go until I get below $9. Let's see, I'm getting close. Sorry, I did not do this ahead of time. So $9.16, $9.10, almost there. $9.05. I could have guessed and checked some bigger values. Let's see. There we go. I'm less than $9 at 201 yearbooks. So 201 yearbooks make the cost less than the $9 per yearbook. All right. Let's see. Find the vertical asymptote. So I said, when will the function be undefined? You want to look very carefully at your denominators. You can never divide by 0. So what would I have to plug in here? I would have to plug in positive 10, because 10 minus 10 would give me 0 in the denominator. So x equals 10 is called a vertical asymptote. This one would be at -1, and this one would be at 0, because 5 times 0 would give me 0 in the denominator. So now they want you to plug in the number 0 for x, the number 2 for x, the number -1 for x. So pause the video, because it's very important that you know how to do this either mentally or using a calculator, and then you can check back to see if you got the right answer. I like to just do these by plugging them in without my calculator. 0 plus 6 gives me 6 in the numerator and -10 in the denominator, or -0.6 if you divided it on a calculator. Plugging in 2, I would get 3 in the numerator, and I would also get 3 in the denominator, which is the same as the number 1. And let's see, 2 times -1 plus 1 over -5. When I plug in -1, -2 plus 1 is -1 over -5 is positive 1/5. Or if you did it on a calculator, you might have gotten 0.2 as your answer. All right, so this is very important to be able to evaluate. So I'm going to multiply this 10 to the other side of the equation. So I have 2x equals, I'm going to distribute this 10x plus 20. I'm going to subtract 10x from both sides. So I have -8x equals 20. All right, divide by -8 on both sides. Oops. So what is 20 divided by -8 is -2.5. So x is -2.5. This one you might be able to do in your head. 3 times 6 is 18. What number times 6 is 24? So x has to be 4 on this example. All right, this last one, multiply x to the other side. So 4 equals 8 times x. Divide by 8, and x would have to be 1/2. All right, so we're matching the equations in number 4, which was way up here at the top, to their graph down below. So let's just look. Positive 10 was the vertical asymptote for a of x. Positive 10 is the vertical asymptote here. So this must be a of x. B of x had an asymptote at -1. So this graph appears to have an asymptote at -1. So this would be B of x. And our other graph had an asymptote right at x equals 0. So this must be C of x. And I wrote this note so you will not have to find horizontal asymptotes on your final exam.